All right, let's continue on here. Now notice that I did end up writing this over to the side again, so you will need these. And it looks like we have two things to do. We need to solve from 0 to 2 pi, and then we need to find the general solution, so all of the infinite solutions. And also notice that these are squared. So these are going to be questions where there's going to probably be some sort of factoring involved or something like that. So everything is onto one side, so I could actually factor right now. So this is going to be a 2 sine of x and just a normal sine of x. And if you multiply those, multiply those together, you get 2 sine squared, which is what I have on the right. Or sorry, on the left. And on the right here, I need 1. Negative 1, so one of them needs to be negative. So if I just look at the numbers, multiply those, you get negative 2. Multiply that, you get positive 1. And if you add those together, you get a negative 1, which is what I have in the middle. I've got a negative 1 sine of x. So that lets you know, if you know how to factor, then you can factor a different way, but that's how you would know this way that you have factored correctly. So once you've factored it, you can write it down. You have 0 equals 2 sine x plus 1 and sine of x minus 1. Now these are really long questions, just so you know. They're very very time consuming. So you can have 2 sine of x plus 1 equals 0, or sine of x minus 1 equals 0, which is what we had up here when we first did this question. This is the exact same one, and we factored it, and we had 2x plus 1. Now we have 2 sine x plus 1, and then we had sine x minus 1, and up there we just had x minus 1. And so once we did that, you can make 2 of them, and you could solve them individually. And so that's what we're doing here. We've got one question, and then we factor it, and we create 2 questions that we can solve individually. So here, we can just add the 1 onto the other side. You have sine of x is equal to 1. Then here you can add minus the 1 to the other side, and then you can divide by the 2. So divide by 2, divide by 2. So sine of x equals negative a half. That is not solved. That is just to the starting point. Now we're at these questions. Sine of x equals a half. So that's where we are. All of that work, and we're just starting what we did before, which is why these take so long. So sine of x equals negative a half. We actually already did that question, but it's good just to remind ourselves how to do that. X are here, the element, the reference angle. If we're looking for a half, and we're looking for sine, sine. So sine is on the right, so half is right here, which is pi over 6. So we're going to look at a reference angle of pi over 6. And so when we do our drawing here, I can label this as 6 pi over 6 and 12 pi over 6. And then I can take a look at my angles. Now, sine is negative. Well, it's positive here and positive here, so it's negative in these two. So my angle here would be, knowing that this is pi over 6 as a reference angle, and knowing this is pi over 6, my answer would be 6 pi plus a little bit more, so 7 pi over 6. And then this one would be not quite 12, it's a little bit shy, so 1 shy, 11 pi over 6. So those are my answers for that one and this one. And it's usually like this, where there's one that requires a normal amount of work, and then usually there's one that's a little bit easier. So sine of x equals 1. So sine again is on the right, and 1 right here. So that happens at pi over 2. And then this is negative 1, so that's not what we want. So just pi over 2. So the angle is pi over 2, which is not a reference angle because it's on the axis there. So just pi over 2. So those are my 3 answers. So there's definitely a lot of work that went in there. And we can do basically the exact same thing again for this one, for B. The only problem is that we have to bring these things over. So let's bring them over right now. We'll subtract them over. Minus the cos of x. And minus the 1 over to this side. So then those are gone and those are gone. So I've got a 2 cos squared of x minus a cos of x minus a 1 is equal to 0. And then I have to factor this again like I did. So this would be a 2 cos of x. And this is just a single cos of x. So when you multiply them, you would get a 2 cos squared, which is what I have. And this side needs to be a 1 and a 1, and this needs to be negative. Again, the same reason, is because when you multiply that, you get negative 2. When you multiply that, you get positive 1. And if you add those, you get a negative 1, which is my middle number. My middle number is a negative 1. So I'll erase this. And this is these are my 2. So I've got 2 cos of x plus 1, and just cos of x minus 1 equals to 0. So we've got two options. We have 2 cos of x plus 1 is equal to 0, or just a cos of x minus 1 equals 0. And then, like we did here, the previous, you can just move over the 1 and then divide by 2. So 2 cos of x is equal to negative 1. Divide by 2. Divide by 2. So cos of x equals negative a half. And on the other one, you can just move over the 1. And like I said, usually one of them requires moving over a couple of things, and it's a little bit more involved. The other one's pretty simple, straightforward, pretty simple. So I've got two things to solve. The first one here is the one that's a little bit more involved. It's one where cos of x equals negative a half. So I need to take a look at when cosine is a half and look at that from my reference angle. So cos is on the left. Okay, so I'm looking for a half. Okay, right here. So pi over 3 is my reference angle. So I'll just write that down, pi over 3. And then when I draw this, I'll label this as pi. So this will be 3 pi over 3 to give me the pi, and 6 pi over 3 to give me the 2 pi. And then I need to do the cast rule, and I'm looking for when cosine is negative. So it's positive in the all, and it's positive in the C quadrants. So I'm looking at an angle there and an angle there. And I know that this is a reference of pi third. Pi a third. So when I do this, this angle would get me, it's not quite 3 pi over 3, it's shy, so 2 pi over 3. And then this one is past 3 pi over 3, a little bit past, so 4 pi over 3. So those are my two answers. And if the other one, I'm looking for when cos of x equals 1. That's what I'm looking for, and that should be on an axis, I imagine. So again, cos is on the left, and when is it 1? Oh, right here. So it's at 0, when the angle is 0. Here it's negative 1, that's not what we want, we just want positive 1. So when the angle is 0. So when the angle is 0. So those are my three. Now one thing that I didn't do, that I need to do, is the general solution for both of these. So when it comes to this, you need to just, maybe I'll do this in green, we need to do the period. So the period for this, now it's just cosine, so cosine has a period of 2 pi. So therefore, when we do our this is to letter B here, when we do our B, we would just write down all of the answers. So 0, 2 pi over 3, and 4 pi over 3. And I like to put them in brackets. I say all of these, plus you can add the period, and that would get you in the exact same spot. It's called coterminal. So it'll get you in the exact same spot, and you can do it any number of times. So we'll go n for any number of times. 2 pi times n, where n is an element of the counting numbers. And so I like to list them all, put little brackets around it, and any of these you can add 2 pi n to them, and they'll give you the exact same answer. Now over here, sine. Now sine also has a period of 2 pi. So sine and cosine both have a period of 2 pi. Tangent has a period of just pi. So when we do our answers, we'll do all of them. So we'll do, okay, we got x equals, there's a pi over 2 from here. And then we have a 7 pi over 6 and an 11 pi over 6. So all of these, and you can add any one of them, you can add 2 pi as many times as you want. So 2 pi n, where n is an element of any integer, any kind of counting number, positive, negative, or 0. So that is how you do it. You just list them all down, plus the period n, where n is an element of the counting numbers. So I'll zoom this out here. The PDF probably looks a little bit nicer, but at least you can see a little bit of this here.